All right. What's going on, everybody? Thank you so much for coming out and being a part of this. Hey, 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 I see some hands waving. I appreciate all y'all. Today we're going to be doing a TypeScript talk. Some of y'all may have heard some parts of this before. I've referenced it in the past. But my goal with this talk is to do something a little different than a traditional TypeScript talk. And to give you an idea, a lot of the talks that I've ever done, written, or spoken in the past, they've come to me because of situations or instances that remind me like, this would be really good to share with somebody. And so the ultimate goal with this talk is to, number one, we're going to be obviously doing some kind of intro into TypeScript, but with the ultimate goal really being the advanced side, because I know we have some beginners in here, we have some experienced developers. I kind of want to hit all aspects here. But to give you an idea, I was working at a company called AutoZone, and when I was at that organization, it was the first time I ever worked at a company where we weren't building the application from scratch, where we were introducing the aspects of TypeScript to it. It was my first introduction into an existing code base, very massive, all over the place, some really great parts, some parts not so great, and as they do. But as I was going through the code base, I started realizing something really early on. Like, I feel like I'm basically getting used to this code base significantly faster than any other time that I've ever been in an organization before. I've worked in plenty of organizations, Fortune 500 and et cetera, but I'm like, why is it this specific time I'm adopting this code base way faster? And I started realizing because of TypeScript, I was obviously understanding what items are going into things, how we're utilizing it. It's almost an extra form of documentation, really explicit. And I started realizing this is a much better experience. And because of that, I thought it would be really good to kind of dive deeper into the world of TypeScript, which I've done. I've been writing TypeScript for years at this point. And so I kind of wanted to go through some of the intricacies and at least more real-world situational items that you may come across. I've built an app that we're going to kind of go over as well, kind of go through the code. Obviously, we're going to be kind of experiencing a lot with there. It's an application using a database as well, so we'll kind of see some things there where we can kind of get some values out of that. And overall, I think it should be a good experience. So let me kind of go through this a little bit. So just out of curiosity, show of hands, how many of y'all have ever seen me give a technical talk before? Hey, y'all are in for a treat, I guess. So I don't really like doing the show of hands. So if we can, I want to do a little test with you real fast. I like this cadence, bop, bop, bop. So I don't need you to stand up. I don't need you to do anything like that. But if you agree with something or you're in the affirmative with something, if you can do this, please do that as an affirmative, all right? So to test this out, if you're at all things open, can you give me a bop, bop, bop? Great. How many of y'all have used JavaScript before? If you've used JavaScript, give me a bop, bop, bop. There we go. How many of y'all have found bugs in your code and have used the console to try and solve it? Bop, bop, bop. I like that. How many of y'all have hacked into a government website? Oh, the camera. Got one. All right. So, going with that, here are some facts. So I want to approach this topic from not just a technical standpoint of, oh, I like TypeScript. I want to take the business aspect into these. So we got some interesting facts here. Number one, TypeScript is the 4th most popular language on GitHub right now by the number of contributors, demonstrating its widespread use in open source projects. Obviously, this adoption and this very quick rise has not just been because of hobbyist developers. Because when you see, for example, Rust, it's not in that top tier category as well, even though it's very beloved by a lot of hobbyist developers. And some organizations are definitely adopting it right now, but it's not at the level at that what we're seeing the adoption of TypeScript as of right now. The number of TypeScript-related packages and their downloads have been increasing, indicating a growing ecosystem and adoption in the JavaScript communities. Because of that, you can kind of see, obviously, again, at the enterprise level, this is being adopted at a wider rate. We can kind of also conclude this by seeing this very detailed number here. In October 18th of 2020, there were 14,815,494 NPM downloads for TypeScript. Last week, October 17th, 2024, 63,460,765. That is, again, not hobbyist. So when you're considering enterprise-level organizations, obviously that adoption rate is increasing, but the real big focus that I want people to have here is when you're looking at trying to start garnering and getting stronger tech talent. If you're not utilizing the tools where a bulk of them are, and I know people say, well, I go back and forth, I use JavaScript. If they know TypeScript, they can go back. But think about it from the developer experience standpoint. If you're already utilizing and used to the world of TypeScript, you don't really want to go back to not strict typing. It just feels like a very big hurdle, if I'm being completely honest. And so thinking about that, TypeScript rise in popularity. In 2023 alone, TypeScript overtook Java for the first time as the third most popular language across open source projects on GitHub, with 37% growth of its user base. And this is one of my favorite ones. TypeScript is the second most loved language with 73.1% of developers, according to the Stack Overflow survey of 2023. Supporting this a little bit, 38% of bugs at Airbnb could have been prevented by TypeScript, according to a post-mortem analysis. This was released by the Airbnb engineering team. They did an entire talk on this. It's been a couple years now, but that one stat alone really stuck out to me because it just shows. And people, kind of combat this, like, oh, if you just do this and you do this style of typing or you do this style of programming, you can kind of just avoid the need of TypeScript. When you have large-scale teams saying, hey, we're still letting bugs through, or we're missing certain things, like, and I have a couple examples that we'll kind of go over, but one common bug that you kind of see is like a number in a string, JavaScript doesn't catch it, it doesn't go in the console, it goes into the checkout page, for example, so now you have the wrong price being shown, loss in customer trusted with the product. It's a very avoidable mistake. And so for them to even come out and say, hey, this is a big issue, and so now we've adjusted this and we've kind of adopted it in our organization as well, I think that's something to pay attention to. But the other thing that I thought was really interesting, 15% of bugs on GitHub can be prevented with static typing. According to a research study including the Microsoft and the TypeScript teams, they did an entire research survey. I included the link there if you want to type that out. But essentially this entire research study, I think it was like a 20-page research thing that they did, concluding and kind of compiling all their data and research over repos, and 15% were just bugs that could have been avoided with static typing. So I think that right there from a business use case makes a lot of sense when you are talking about larger scale teams and trying to avoid some of those issues. And this, comparing stats right now, this is from the 2024 Stack Overflow survey versus the 2020. In 2020, Stack Overflow, TypeScript had a 28.3% usage with professional developers. When it comes to professional developers in 2024, we're now in the top 5, which is a huge jump, and 43.4%. Because of that, we saw a 54.59% increase in usage with professional developers, obviously jumping up the ranks now from being in the top 10 to the top 5, and it just kind of shows where it's being utilized within that hierarchy, and I think that goes a really, really long way. So I know what you're thinking. Amazing photos, yes, I agree. But this was literally taken at AutoZone when I was kind of dealing with a very, very big problem, and I said, there has to be obviously a better way, but I was trying to, and I'll tell you this, we had a project utilizing AngularJS, and we had to start thinking, how do we migrate this behemoth to a more modern stack utilizing React and stuff like that. And so there's no strong types that we can utilize or reference because everything is kind of in that old deprecated state. And so we started trying to come up with a plan. And so when you start using some of the modern architecture, it's a lot easier to do. And so we can kind of go through this. And so for me, why is TypeScript worth learning and using? And I'm going to kind of explain one thing here. For me, the biggest immediate advantages are code readability and catching errors at compile time instead of runtime. Now, for some beginners, this one really messes them up. They don't really see the big distinction. So I kind of want to explain this a little bit further. Compile time is when the computer translates your written code into a format it can execute. So it happens before the program runs. It's before anything is running, it's catching that error. Runtime is when your program is actively running and performing its tasks. Now, definitely some verbiage there that maybe some beginners probably still don't get. So I'll illustrate this a step further. I'm going to introduce you to Chef Danny, my alter ego. And I saw some laughs, and I don't know why. I'm amazing at it. But anyway, the way that I like to explain this is imagine you're baking a cake and you're following a recipe. Compile time would be checking the recipe, ingredients, and instructions before you start the baking process, before you start mixing the ingredients. You're getting through all of that there, right? Runtime is when you're actively mixing all the ingredients together. So why is this a big distinction? Because, well, maybe the recipe needed 6 eggs and you put in 8. Now you're catching it after you've added 2 in, Why not catch it before you make that mistake and save yourself that time? That's a big distinction, and I think that's why we kind of go a long way with this. And so we'll kind of go over this example here. This is a very basic example, but it's something maybe you could probably see on a checkout page of a website or a shopping funnel. We have this function here. This function is calculate total, so maybe we're adding in a price and a tax, and obviously we're going to be returning a type of number, and inside of that return we have our price plus tax. So with JavaScript, we can kind of get away with this, right? If we were to use JavaScript and we put that together, it would just show the total being 510. So if we had a customer that was expecting to spend $15 on something, and now they're seeing $510, they're going to obviously be scared to put the credit card information in. They may abandon that cart, and if you don't work in e-commerce, it's roughly around 90% of abandoned carts never get rebought again. So just because of a very basic error, you could end up losing that customer in that process. For what? This could easily be caught. And so in TypeScript, you would see these red squiggly lines, and in doing so, you can hover over that and you would see this pop up. Argument of type string is not assignable to the parameter of type number. So we're catching it right away saying, hey, we're expecting a number to be here. So you can see here as we say price is number and tax is number. So it's expecting this to be a numeric value instead of a string. Because of that, we see it right away. There's no need to reference a console log or visual testing. We can see it right there. All right, so for example here, we have a function where we're getting user data and we're passing in a user ID that we're expecting. And so here we have this URL, right? And so inside this URL, we're using AppWrite, which is backend as a service, as a database. You can get like a lot of your information out of there. It's a really good, cool tool. They have authentication and all the good stuff. But of course, the database is really fast and easy to use. So if that's something you're interested in, I highly recommend checking it out. But we're passing in user data and we're passing this numeric value for the user ID. But here the problem would be, we're not kind of, number one, saying what the user ID is, and because of that, we could be having an issue here when we're trying to pass that through. So here, TypeScript enumerates the data, and it has a name property of type string. So if I were to put the wrong type, for example, of a number, it would catch it, or if I put a string when it's expecting a number, it would catch that mistake as well. So the error message would show in that situation, property name is missing in the type of age number, but it's required in the type of user data. So as you can see here, we're looking at this response for then data, and we're giving the name type string. So if anything else besides string were to come back, we would catch the error early on, and we can avoid some issues there. Now, we're kind of diving into a little bit to interfaces and how we can start utilizing, or honestly, the reusability aspect of TypeScript is kind of where we get into this. So here we have an interface of user where we're passing in a basic example of name and age. So name would be obviously a string and age would be a numeric value. So here we can have the example of Alice and she's 25, right? Now, if we were to jump in one extra step further, we have an interface of address, and we're passing in an address here, and we have an interface of user, where we have the user's name and age, and now we can pass in that interface of address automatically there, instead of having to manually type that every single time. That reusability aspect starts kicking in, and we can use it as an object right there and fill that information in. All right, now obviously I'm not saying thank you for attending. It would be nice to finish that fast, but I'm gonna kind of show you this application that I made. And so let me kind of go here and go back to this and mirror, and now we're good. All right, so for those that may know or may not know, I've been on this whole weight loss journey. I'm trying to lose more weight, and so one thing that I was doing was kind of logging the calories of the food that I've been eating so I can be more mindful of my choices. And when I was doing so, I realized, it's a pretty basic application when you start removing a lot of the tracking or the upselling or all these other items or the barcode scanner. So like this could be a really interesting project to try and start throwing some things into. So I can come here, and you can see here as I have pagination here, so I can go, cycle through the days, or I have this drop down that I'll show in a second. But as I'm going through, you can kind of see all these options that I've placed every single day, so you can see how the progress bar kind of changes there based on the number of calories that I eat in a day, compared to the goal that I have for that day of 2,000, right? And so let me go here, and so we can kind of move, and then so on and so forth, or I can use this date drop down here to kind of go through that as well, right? So let's kind of look at this code a little bit. And so obviously, since this is all things open, I call this the all things open fitness app, and so, got to keep with the theme. We definitely have a lot that we're gonna kind of cover, and I wanna see if this is legible for y'all. Is this easier to read? All right. You think I need to move in one more step, or we're good? All right, perfect. So we've got a couple things here. So we have our assets, we have our public directory. One more? All right. We good now? I love it. All right, we're doing this together, y'all. So we have our interface here where we have an app.tsx, we have our components file, asset file for the image that we use, we have some conditional types and modal types that we're going to be kind of going over, and we have an inference for in our utils file that we'll be going over. So as you can kind of see here, we have some imports that we'll go over in a moment, but here, for example, our conditional type of get calorie response, get property above that in our utils, and then our calorie response is kind of listed there that we'll go over in a second. So right here we have our interface for our app document, and essentially what we're saying is when we're pulling this response from AppWrite, these are the fields that we're expecting, and these are the types that we're expecting. So if something else comes up, obviously that's not what we want. We want to log an error at that point, right? And so to kind of give you a basic of generics, if you're not necessarily familiar with them, and this can kind of help out here. Here we have a type, and we're using calories total, and here we're passing in our type of T calories. And so you can kind of see here now that I have an additional type of daily calories total, and I'm passing in the calories total here, and I'm giving it a calories of number, a numeric value. And when I hover over this by utilizing it like that, the reusability aspect, you can now see here I have data in an object with calories being the number. So because of that, I can pass in data for T calories and just start going through it like that. And so that's where generics really start getting powerful in my honest opinion, and where you can start using it. And so I'll comment that back out. So hopefully that kind of clears that up a little bit. And let's kind of go through this. So I didn't originally have comments for this, and by the way, this repo is on GitHub. So if you want to kind of follow this on your own, or maybe you want to kind of follow some of the comments, I try to add comments so that way it's a documentation base so you can kind of get familiar with it. I didn't originally have this commented, but when I was going through this in my Discord, someone was kind of confused with this, so I added this in here just as a way to help. A helper function that I'm using here is called getCurrent local date time string, and essentially it's a helper function to get the current date and time in the local time zone by having a string format being returned here. So this part apparently confused quite a few people, that we're putting the explicit the type of that before the arrow function, and when we're returning it, basically we're saying anything that we're returning, it's going to be this type at the end when the arrow function comes back. Hopefully that kind of makes some sense. But basically, anytime you put that type, we're basically saying anything we return, we want it to be that type. So if I did this as a number, I'd expect whatever I'm returning to be a numeric value instead of this string. And here, this one apparently really caught some people up, so I added this comment as well. This one, we're formatting date, and it's a helper function, obviously, to format the date in the format of month, day, and year. Before this function, we were saying that we want to return the type as a string, so same concept above that we utilized. And this is the one that kind of confused people. So I'm using an undefined before I'm doing the object of month, day, and year. And people were confused by this, but essentially the undefined here is used to default to the locale of the JavaScript runtime. So hopefully that kind of makes some sense for y'all and kind of clears that up. So as we go through this application, we can kind of see we have a modal state that we're going to be going over. We have our calories. Of course, the goal for my daily calories for myself was 2,000. Obviously, you can adjust this to whatever it is that you need. And now we're using some pagination. So we have the get previous day and get next day. So to kind of re-reference our application again, we have our previous day here. So if I deduct a day, it will change that date automatically. Or if I press the next day, it will add that day. And the best part about that, too, is from the API response, it's basically cutting off any other options that would be outside of that date, so we can make sure that we're only seeing the relevant information. So our first intro into generic functions. The function takes a date. As you can see here, we're doing fetch and display date, and we have an async action that we have our type that's extending our app document. So if you remember at the top, we defined our app document here with everything that we wanted to see, whether it's the ID, the created at, the food, the calories, etc. And we're coming back here for our API response. So we have our date, which is obviously the date that we're selecting through pagination, and the page number. And we're basically saying we want a promise, and the promise is our calories response, whether it's going to be success or error. This means the function will return a promise that resolves to a calorie response object, and this object will either contain success or error for us to kind of know where we're going with this. And so as you can see here, with AppWrite, they have, and I guess I should probably have this open so we can see the database and see what's happening there. I apologize for that, I didn't think about that for a second. So you kind of see here we have our calories and we have our food, and you can see if I add something in real time, we'll kind of see that. So let me just add that real fast. So test, and we'll put that as 500 calories, and we can add that. And then, obviously we don't see it there, but if I were to go to our current date, which is, what is today? The 29th. Now we see it. So it sends it in real time, it comes back extremely fast, and if I refresh this page, we now see our test data showing the food that was utilized. Very easy to do, to be honest with you. It's just a couple lines of code right here, and the documentation is pretty good at just, you can follow it, it's not that difficult. It's actually really well done. But in our response, we have our database ID and our collection ID to make sure like we're getting the accurate API response. Of course, the API key and all that good stuff is in another file that we're using environment variable for. And then from here, we kind of see our get documents ID. So we're filling in now our entire interface of what we're expecting for app document above. So doc, we're getting our ID, the created food at, and with food, we're doing a get property. So right here, we're kind of using a util, and essentially the idea here is you can see that I have a type of T going into K and an extensive key of T. So basically I'm saying I have a type, and in here I'm basically going through the keys, and if it's valid and it matches the type that I want to return that object with its key. And so as we can kind of go here, and we're setting our calories now. So set the calories, basically saying, hey, these are the calories that we're accepting, and kind of deduct it from there, and through some CSS, you will then see this bar essentially change. And from here, we can kind of go down a little bit further. It's hard to see when everything's so zoomed in. Oh, it's in this next file. Whoops, the modal. So now as we go to our modal, this is where things start getting a little bit more interesting because we're going to be introducing our modal type. So let me go to modal type first. So here we have something called a discriminated join. And so you can kind of see here, number one, we have our interface of modal closed, and it has a state of closed. And here we have our second interface of a modal open, which has a state of open. Because these two options, or these two interfaces, have one item sharing similarity, which is the state, we can use a discriminated join. Discriminated join, sorry. I was thinking SQL talk. Discriminated union. A discriminated union is a pattern in TypeScript that combines union types with discriminate properties to enable type-safe differentiation between different variants of the union. It is particularly useful for modeling. To be honest, most of the time, if I ever use it, it's probably going to be a modal state or something along those lines. It is particularly useful for modeling situations where an entity can be in several distinct states, each with different properties. So you can kind of see here, when I'm saying export the type of modal, I literally have a pipe in between modal closed or modal open. So I'm basically saying it could be one or the other by using that discriminated union. And so if it's in the open state, we now have two extra fields because of that value of closed or open. So I can have my food item there as well as my calorie count, which could either be a number or a null value. Modal state is the union type that can be either modal closed or open. And as I go through the calorie table, which is this table here that we see where the calories are kind of displayed, we see here that we have a read only because I don't want anyone to be able to change these values because we're just displaying it, right? So I have a read only type added to these calories. So we have our food, calories, and the date that is shown. And we have a read only array of calorie item, so that way it can just be displayed in the way that we decided to. And then some basic styling for the table. And now as we go through conditional types, for example, we have this conditional type of success that we saw originally here, right? Kind of go back to that to reference it, if I can see. Here, so our promise of calorie type, so we have our calorie response that we're expecting a type of T. So T extends success. If it does, I want to see that data and it's going to be a type document. Otherwise, I want to see the error being a string and we want to actually see what that error could possibly be for us. And from there, we can kind of see, oh, I've already gone over get property. And I think that's pretty much it in this regard, if I'm not wrong. Oh yeah, kind of going over the progress bar. So as we go through this progress bar, we have our progress bar props. We're passing in here our progress, obviously, and the goal number. So that way we can know what's the caloric change that we need to see. And in doing so, we're actually developing this radius. And essentially with this, the circle radius, we're kind of basically stroking what this is going to look like. So the percentage points will end up filling this bar. And of course, if there's any excess values past 100%, it would just remain full instead of going back to the way it was. And so then we can display inside of the circle our daily calorie goal. And what that goal is, obviously, we're passing through a variable here that you can kind of see inside the center. So if you change that numeric value, it'll showcase it in that way. Outside of that, I think that's the entirety of the talk. And so thanks for attending. Really appreciate y'all, and hopefully you gained some knowledge about TypeScript.